In this part of the data structure course related to dynamic memory, through the example class called dynamic class that we covered in the previous part, we will examine the issues related to copy constructor. Now we will see the details of assignment and initialization. Assignment and initialization are basic operations that apply to any object. The assignment by assigned value x causes a bitwise copy of the data from object x to the data in object y. However, initialization creates a new object that is a copy of another object. The operations are illustrated with objects x and y. For the initialization, consider this code. Here we are declaring an object x with parameters 20 and 50, and this object is of type dynamic class int. Here there is another declaration, y. It is again of dynamic class integer object, and notice here that it is initialized with the values given here for x. This line creates dynamic class objects x and y. Data in y is initialized by data in x. Now we are considering the assignment. In the assignment, we have an object in the left-hand side, and then this is for the assignment, and the data in y is overwritten by data in x. Here we have assignment. Here we have assignment. In this line, y is assigned value, whatever, for the object x. By this assignment, data in y is overwritten by data in x. Special consideration must be used with dynamic memory so that unintended errors are not created. We must create new methods that handle object assignment and initialization if we have dynamic parts in the object. Now let's consider first the assignment issues. Suppose that in the system memory, we have an object here, and we have member 1 for the object A, and member 2. Member 2, in fact, is a pointer to a dynamic object, and this is the object pointed by the member 2 of the object A. Here on object A, we are considering the data member 2. It's a pointer, so by this star, we are considering the item pointed by this pointer. We have another object, object B, and this is the member 1 of object B, and member 2 points an item. Here it is created dynamically, and this is the item pointed by the member 2 of object B. The assignment statement of B assigned value A causes data in A to be copied to B. Member 1 of B assigned value member 1 of A. This copies static data from A to B, and also member 2 of B assigned value member 2 of A. This copies pointer from A to B. Here there is an example to show the assignment issues. We have a function f. There is no parameter as input, and there is no output of the function. Within the function, an object named A with parameters 2 and 3 is declared of type dynamic class int, and also another object B with parameters 7 and 9 is declared here. And then we have an assignment, B assigned value A, and this is the end of the function. After execution of the line, this line, dynamic class integer A 2, 3 and B 7, 9, two objects are created. For object A, we have value 2 here as a member 1, and we have value 3 for the object pointed by member 2. And for the object B, we have 7 and 9 in the corresponding positions. After the declaration statement, we have assignment statement here. When it is executed, we will have object A, which has same value as previously shown here. However, the static part of the data in the object A is copied to object B. So this value 2 is copied as the member 1 of object B, and also the pointer here copied to the member 2 given here. Because this pointer has a value such that it points to the item have a value 3, this time we will have a pointer here points to this item. In fact, we would like to have object A as before. However, for the object B, we would like to have value 3 here, and here the pointer to point this item instead of this one. The solution is overloading the assignment operator. Overloaded assignment operator equal returns a reference to the current object. So here there's a reference to dynamic class of type T object. Here T is a template class for the template implementation of the assignment operator. Here we have a parameter which is called RHS, right hand side. This is of type dynamic class T reference, and it's a constant. In the assignment operator, first we copy a static data member from RHS to the current object. So member 1 of the current object is assigned value, the member 1 of the object called RHS. It is the one sentence parameter. And also the content of the dynamic memory must be same as that of RHS. For this purpose, the object pointed by member 2 is assigned value same as the object pointed by the member 2 of RHS. After that, we have an output statement showing that the assignment operator is called, and then we see member 1 / member 2 at the output end line. And after that, we have a return which is returning the item pointed by this. The reserved word this one, is used to return a reference to the current object. So it will return the item on which this assignment operator is used. In the main part, let's have a declaration of dynamic class integer object A with parameters 2 and 3, and also B from dynamic class int having parameters 7 and 9. And here we have again the assignment B assigned value A. But this time, because the assignment operator is overloaded, this function will be called. This return value is necessary for assignments like that. Here we have A assigned value B, assigned value C, and notice that this is implemented from right to left. First, C is the right-hand side given here, and this is the object shown by star this here in the return value. On the object B, the assignment operator is applied, for which C is the right-hand side. After this assignments for the member 1, and the object pointed by member 2. Then star this, the object pointed by this is returned. Because in the left-hand side we have object B, this is a pointer pointing to object B. So star this is corresponding to this object. For this assignment, B becomes the right-hand side, which is the object pointed by this. Again, the assignment operator is called for loading the values in B to A. B assigned value A is equivalent to, on B, we applied operator equal, this is the assignment operator, and A is corresponding to right-hand side. B is the current object. We are using assignment operator, and this is the right-hand side, RHS. Now let's consider the initialization issues. Object initialization is an operation that creates a new object that is a copy of another object. Like assignment, when the object has dynamic data, the operation requires a specific member function called the copy constructor. Consider the declaration given here. A is a dynamic class integer object with parameters 3 and 5, and then we have declaration of B, which is initialized with A. The declaration of A creates an object whose initial data are member 1 is 3 and the object pointed by member 2 is 5. The declaration of B creates an object with two data members that are then structured to store the same data values found in A. In addition to performing initialization when declaring objects, which is the first case, initialization also occurs when passing an object as a value parameter, which is the second case, in a function. For instance, assume function f has a value parameter x of type dynamic class integer. This is the return value from the function f. It is of dynamic class type. And here we have a parameter x, which is also dynamic class integer type. Inside the function, there is a declaration of the dynamic class int object, and it will return the object. When calling block uses object A as the actual parameter, the local object is created by copying A. Dynamic class integer object A with parameters 3, 5 and B with parameters 0 and 0 is declared here. And then there is a call to the function f with parameter A, which is corresponding to x here, and it is assigned to B in return. When the return is made from f, a copy of obj is made by copy constructor, and this is the third case. The destructor for the local object x and obj are called, and the copy obj is returned as the value of the function. So if you consider the first case, here there is a declaration and there is a call to the constructor. The second type of call of the constructor is here. There is a call to the function with parameter a. When the function is called, a is corresponding to x, and here x is created such that whose initial value is same as a. This is the third case. Here there is a return from the function f, return obj. For this return, a copy of the object to be returned is created by the copy constructor, and it is returned from the function. Before that, whatever declared in the function is destroyed, and also the parameters are destroyed. Now we will consider the implementation of the copy constructor. In order to properly handle classes that allocate dynamic memory, C++ provides the copy constructor
to allocate dynamic memory for the new object and initialize its data values. The copy constructor is a member function that is declared with the class name and a single parameter. Because it's a constructor, it does not have a return value. This is the command saying that copy constructor initialize new object to have the same data as obj. It is implemented as a template function. We are saying here template class T. This is the template class. This function, copy constructor, which is named dynamic class, same as the class name, is a member function of the dynamic class of type T, and T is a template class. We have a parameter here, which is of type dynamic class T. Its name is obj. It's a reference here, and it is constant. In the function, the static data member from obj is copied to the current object. So obj member1 is copied to member1 of the object which is just created. And also allocate dynamic memory and initialize it with value the object pointed by the member2 of obj. So we are saying member2 is assigned value, this is a pointer, such that it is assigned the address of the obj created by the new operation. The value of the object just created by the new operation is same as the content of the object pointed by the member2 of obj. Here there is an output statement saying that copy constructor is called, and then member1 slash, and also the item pointed by member2 are sent to the output device, and then we have end line, and this is the end of the copy constructor. If a class has a copy constructor, it is used by the compiler whenever it needs to perform initialization. The copy constructor is used only when an object is created. Despite their similarity, assignment and initialization are clearly different operations. Assignment is done when the object on the left-hand side already exists. In the case of initialization, a new object is created by copying data from an existing object. The parameter in the copy constructor must be passed by reference. Here, consider the copy constructor, and if the parameter pass was by value instead of reference, in that case, parameter pass by value calls copy constructor recursively. Because here parameter pass is by value, there is a call to the copy constructor, and again inside that call there will be another call to the copy constructor, and always this would be repeated. The problem is solved by using reference in parameter passing. Here, instead of parameter pass by value, we have parameter pass by reference. In addition, the reference parameter x should be declared as constant, since we certainly do not want to modify the object we are copying. Now we will consider an example to examine when constructor, copy constructor, or destructor is called, and also the assign operator. The operations for IOStream and also the class dynamic class header is included. The code is written as a template code. Here we have a function, template function. Its name is demo. It will return an object of type dynamic class T. And we have three parameters here. The first one is called one, and it is of type dynamic class T. Then we have a reference to dynamic class T. The name of the parameter is 2, and The third one is m, which is of type t. In the function, an object which is called obj is declared. It is of type dynamic class t, and the parameters are m and m, which is the value provided here. And then there is a return where obj is returned from the demo. Here in the main part, there is declaration of A with parameters 3 and 5. A is of type dynamic class integer, so there is a call to the constructor here. And then there is declaration of B, which is initialized with A, so there is a call to copy constructor, and C is declared here, and it is initialized with 0 and 0. There is a call here to the constructor. And then there is an assignment to C. Here there is a call to demo with parameters A, B, and 5. Whatever returned from demo is assigned to C. Here, notice that A is corresponding to 1 here. Because this is parameter pass by value, there is a call to the copy constructor here. For the second one, we have a reference, so copy constructor will not be called. Also, there is no call to the constructor itself. And if you consider the return value from the function demo, here there will be a return value. The return object is created, which is initialized with obj. Because of that, here there is a call to the copy constructor. And whatever returned is assigned to object C. So there is a call to the assigned operator here. Let's trace the code starting from the main part. Here there is declaration of A with parameters 3 and 5. So this is a call to the constructor with parameters 3 and 5. These are the member 1 and the object pointed by member 2. And then here there is a call to the copy constructor. This is for the construction of B and with parameters 3 and 5, because these are the values stored in A. Then there is a call to the constructor with member values 0 and 0. We come here, there is a call to demo. A is corresponding to 1 here. There is a call to the copy constructor for construction of 1, and the values are 3 and 5. And we continue here. There is no call to the constructors for the second parameter. Here there is declaration of obj. M is in the call 5, so the constructor will be called with values 5 and 5. There is a call to the constructor. This is construction of the obj. There is a call to constructor with values 5 and 5. Then comes here a call to the copy constructor, which construct return object for demo. Obj here has values 5 and 5 as the member values. Because of that, the return object is created with values 5 and 5. And then we come to the end of the function demo. Whatever declared here will be distracted upon return. Here this one is created by the copy constructor. Furthermore, there is a declaration within the function. They are removed from the memory in the reverse order. So first there is a call to the distractor for distracted obj. The distractor is called for obj, which has values 5 and 5 in the member parse, and this is distract obj upon return. And also the parameter 1 given here is distracted upon return, which has numbers 3 and 5. The return object comes here and it is used for assignment operator. So there is a call to the assignment operator. Here the return object has value 5 and 5 as the member values. And then the return object is destroyed. Destructor is called for the return object which has member values 5 and 5. After that, we are at the end of the main part. So the objects declared here are to be destructed in the reverse order. First, C is destructed. C has values 5 and 5 because there is an assignment here with the return object which was 5 and 5. So here C is destructed when the code exits from the main part, and also B is destructed, for which the data members were 3 and 5, and also A is destructed with these data members. Therefore, all the objects declared in the main part are removed from the memory. They are destroyed also.